Hello, mathematicians. Today we're going to be multiplying and dividing in scientific notation. But before we do so, we're going to review adding and subtracting in scientific notation. So here I have two examples, and if you recall, when we add and subtract in scientific notation, it's a lot easier to first convert into standard form and then convert back into scientific notation. So that's what I'm going to do now. And I'm just going to add as I normally would and make sure to line up your place values. All right, and once I add it, I'm just going to convert our number into scientific notation. I'm going to find out where my decimal goes, and then I'm just going to count the spaces to know what power to raise my 10 till. Okay, and I'm going to do the same thing here, except this time I'm going to subtract. And make sure to line up your place values when you subtract. All right, and once I've done that, now I'm going to convert my number into scientific notation. And that's it, and then I'm done. So what we're going to do now is we're going to multiply and divide in scientific notation. And in order to multiply, we could write these out in standard form and multiply it out. However, I'll end up with two very large or very small numbers. So another thing that we could do is because we're multiplying all four of these numbers, we could multiply these first, and then we can multiply 10 to the power 4 times 10 to the power of 2. And that's because if we multiply 2 and 23 hundredths and 4 and 3 tenths first, and then we multiply these, we could see that 10 is raised to a power, and we know how to multiply when our base is the same and we're multiplying with exponents. So I'm going to multiply these first. 2 and 23 hundredths times 4 and 3 tenths. And remember that when we're multiplying with decimals, we don't need to line up the decimal. And I'm just going to multiply that. 3 times 3 is 9. 3 times 2 is 6. 3 times 2 is 6 again. I'm going to add a place value holder here. And then 4 times 3 is 12. Raise the 1. 4 times 2 is 8, plus 1 is 9. And then 4 times 2 is 8. I'm going to add these up. And here, since I have 3 digits in total after the decimals, I'm going to move my decimal here. So that's what we get when we multiply these two. And now I'm going to multiply 10 to the power 4 times 10 to the power 2. And since the base is the same, I keep my base and I add my exponent. So I end up with 10 to the power of 6. And so my final answer and we could see here that our final answer is in scientific notation because our value here is between 1 and 9, our first digit here. And we're multiplying times 10 to another power. So we're going to do the same thing here for number 2. We're going to multiply 9 and 8 tenths times 3 and 8 tenths. So here 8 times 8 is 64. And 8 times 9 is 72, plus 6, 78. Add a 0 as a place value holder. 3 times 8 is 24. Bring up my 2. 3 times 9 is 27, plus 2 is 29. And then I'm just going to add these together. And so I'm going to see how many digits are after the decimal, which is 2. So my decimal goes here. I have 38 and 24 hundredths. And now I'm going to multiply my 10 to the power of 2 and 10 to the power of 5. And remember, when we're multiplying with the same base, we add our exponents, so I end up with 10 to the power of 7. And here my final answer is 38 and 24 hundredths times 10 to the power of 7. However, even though we multiplied correctly and we did everything right, you'll notice that our digit here is not between 1 and 9, so we do have to change that. So 38.24 is the same thing as 3.824 times 10 to the power of 1. So that's this here. And all I did is change that into scientific notation. I'm going to bring down my 10 to the power of 7. And here I can multiply these because the base is the same. And that's my final answer. So if we end up with a final answer that is not in correct scientific notation form, we do have to change it. So these two are equivalent, however, one is in scientific notation and the other one is not. So that's why we had to change it. Alrighty, here we have 2 more examples, and we're going to do the same thing. So I'm going to multiply these first. 2 times 4 is 8. 2 times 1 is 2. Place value holder here. 5 times 4 is 20. Bring up the 2. 5 times 1 is 5, plus 2 is 7. And then add these together. And now I'm going to see where my decimal goes. 1, 2. So I could go 1, 2. Now we have 7 and 28 hundredths. And now I'm going to take my 10 to the power of negative 2 and 10 to the power of negative 3 and multiply those two together. And here our base is the same. So we're going to take our exponents and add them together. So I'm going to end up with 10 to the power of negative 5. And now we're going to put these two together for a final answer. We have 7 and 28 hundredths times 10 to the power of negative 5. And that is in scientific notation, so we're all good. So last example, we're going to do the same thing. We're going to multiply these two together first. And remember that when we're multiplying decimals, we do not need to line up the decimal. It's not like addition and subtraction. So 4 times 2 is 8. 4 times 3 is 12. Bring up my 1. 4 times 1 is 4, plus 1 is 5. Add a 0 as a place value holder. 9 times 2 is 18. Bring up the 1. 9 times 3 is 27, plus 1 is 28. 9 times 1 is 9, plus 2 is 11. So I'm just going to add this up. All right, and now I'm going to see where to put my decimal. So 1, 2, 3, 1, 2, 3. We have 12 and 408 thousandths. And we could already see based on this, the number before the decimal is not between 1 and 9. So we're going to have to end up changing it at the very end. So here I have 10 to the power of negative 4 and 10 to the power of negative 5. And if I multiply them together, I add the exponents. And here we end up with 12 and 408 thousandths times 10 to the power of negative 9. So we could see here that this is not in scientific notation form, so we're going to have to change it. Here, this is the same thing as, so mind you, I just moved the decimal to the left. And then I'm going to bring this down. So this is the same as only this number here, times 10 to the power of negative 9. And here I have the same base, so I'm going to add my exponents again. And that's it. All right, so now that we're done with multiplication, we're going to divide in scientific notation, and it's very, very similar. So when I divide in scientific notation, a quick shortcut, as we saw in multiplication, is we're going to take the value before the 10, and we're going to divide that first, and then we're going to divide the bases. We're going to divide the 10 to the power of 2 and to the power of 5, so that since the base is the same, it's easier to divide. So right, so when we divide by decimals, our number here on the outside cannot be a decimal, so we're going to rewrite this by moving this over to the right, And if we move one over to the right, we're going to move this one over to the right once. And we're going to end up with 25 on the outside and 32 5/10 on the inside. Okay, so this is what we're going to end up dividing first. Just going to rewrite that here a little bit higher. All right, so 25 goes into 3 0 times. It goes into 32 one time. So here I'm going to subtract by 25. And when I do subtract that, I end up with 7. I bring down the 5. And 25 goes into 75 3 times. And I have no remainder. So here I have 1 3/10 when I divide. And then we're going to divide 10 to the power of 2 divided by 10 to the power of 5. And that's going to equal 10 to the power of -3, because remember, when we divide with the same base, we subtract the exponents. And my final answer here is 1 3/10 times 10 to the power of -3, and that's it. And we're going to do the same thing for the next one. We're going to divide my first value here by 1 3/10. So I'm going to set that up. So remember, here I have to move my decimal once and I have to move my decimal once. So we actually end up with 24 7/10 divided by 13. So 13 goes into 2 0 times. 13 goes into 24 one time. So minus 13. And here I end up with 11. So I bring down my 7. Add my decimal point here. I'm just bringing it up. And then 13 goes into 117 9 times. And I end up with no remainder. And now I'm going to take my 10 to the power of 4 and 10 to the power of 2, and I'm going to divide those. And I end up with 10 to the power of 2, because remember, when we divide by the same base, we subtract the exponents. So my final answer is 1 9/10 times 10 to the power of 2. All right, here we have 2 more examples, and we're going to do the same thing that we did before. So we're going to divide these 2. And remember, here I can't have a decimal, so I'm going to move it over to the right once, move this one over to the right once, and I'm just going to rewrite that. All right, so 18 goes into 3 0 times. 18 goes into 32 one time. So I'm going to subtract by 18. I end up with 14. Bring down the 4. Bring up my decimal. And 18 goes into 144 8 times evenly. And that's it. So 32 4/10 divided by 18 is 1 8/10. I'm going to divide my 10 to the power of 2, -2, sorry, divided by 10 to the power of 3. And here, remember, I subtract, so I have -2 minus 3, which ends up being 10 to the power of -5. So my final answer here is 1 8/10 times 10 to the power of -5. And that's in scientific notation form, so I don't have to change anything. For number 4, we're going to do the same thing. Going to divide these first. And remember that here I can't have a decimal, so I'm going to move the decimal place to the right once. So 21 goes into 6 0 times. 21 goes into 67 3 times. And then I'm going to bring up my decimal. And 21 goes into 42 2 times. So here I end up with 3 2/10. And now I'm going to divide 10 to the power of -4 divided by 10 to the power of -5. And remember here, this is the same thing as -4 minus -5. So it ends up being -4 plus 5. And I have 10 to the power of 1. So my final answer here is 3 2/10 times 10 to the power of 1. So on this slide, I have an example of some numbers that are not correctly written in scientific notation. And what we're going to do is I'm just going to go over how to change them. So here, 687, the number before our decimal, is not between 1 and 9, so it should actually go here. So I'm going to rewrite this as 6 872 thousandths times, since I moved it over twice, it's going to be times 10 to the power of 2. And then I'm going to bring this one down, 10 to the power of -7 here. And so what's in purple represents this value here just in scientific notation. Here I just brought down my 10 to the power of -7. And so because I have a base here that's the same, we could just multiply them, and by doing so, the shortcut would be adding the exponents. So if I write it properly in scientific notation form, I end up with 6 872 thousandths times 10 to the power of 9. So down here, same thing. The first value we have is not between 1 and 9. My decimal should actually go here. And by doing so, I have 4 3/10 times 10 to the power of -2. And then I'm going to bring this down here times 10 to the power of 5. And we're going to combine, so we're going to multiply here 10 to the power of -2 and 10 to the power of 5 because the base is the same. And we're going to end up with 4 3/10 times 10 to the power of 3, because 10 to the power of -2 times 10 to the power of 5 is 10 to the power of 3. And then we're going to do the same thing over here for these. So in order for this value here to be in scientific notation, the decimal has to be between the 7 and the 6. So that's the same thing as 7 645 thousandths times 10 to the power of 2. And then here I'm going to bring down our 10 to the power of -3. So I'm going to combine these two. So I end up with 7 645 thousandths times 10 to the power of -1. And then finally here, I don't have it in scientific notation. The decimal should go between the 2 and the 5. So in order to rewrite just this value here, it would be 2 5/10 times 10 to the power of -3. And I'm going to bring this down. So times 10 to the power of -4. And here, since the base is the same, I could combine these two. I end up with 2 5/10 times 10 to the power of -7. And that's it.